Okay, thank you. Okay, so my talk is about the type systems, type checkers of Ruby. So before starting my talk, I'd like to do some survey. So I hope that you know already that Matt says that Ruby 3 will have an optional type checker. So do you know this? Okay, everyone knows that. It's fine. Another question is that a big topic about the development of type checker for Ruby is about the duck typing. So do you like duck typing? Okay, about less than the half. It's awesome. Let's start. Let me introduce myself. I'm Soutaro Matsumoto. I live in Japan, and I'm from Tokyo, so it was 3 days ago. Yep. This is first time to me to visit European countries. So now, Europe is Bulgaria to me. I hope that you see this picture. This is a picture of a big gate of a famous temple in Tokyo. So there is a famous meetup called Asakusa Ruby in Tokyo. So they have weekly meetup on every Tuesday. And it's a really nice meetup because that many of the Ruby core developers, including Akira Matsuda or Hiroshi Shibata, they come the meetup fluently. So when you come Japan and if you have time, it's really nice to visit the meetup. So I'm now working as a CTO of Cider. It's a Tokyo-based startup. And I also worked at 2 startups as a technical advisor. And I'd like to introduce Cider. It is a web service to help you reviewing your colleagues' code. So it provides some of our own analysis tools and some open source linking tools. It runs the tools on the pull request and find some problems and give the suggestions automatically. So because we support Robocop and many of our users love Robocop using on our site, so we had an interview with Roger last year's Ruby Kaigi. I also developed a type checker for Ruby. It's on my GitHub repository. You can see the project. And as you know, this is the topic of my talk today. This is an outline of my talk. So I will first explain the latest plan for Ruby 3. And then I'd like to introduce my type checker called Steep. And then I'd like to share the progress of the type checking development project. This is a picture from the Matt's keynote from Ruby Kaigi this year. And as you know, he has 3 big improvements on Ruby: performance, concurrency, and static analysis. And we are working on the 3rd topic, the static analysis. So this is the people who are working on this project. From the Ruby core team, we have Matt and Koichi Sasada and Yusuke Endo. And some of the type checker developers around the world are joining the team. So we have some people from the Stripe, including Dimitri, and some people working for Solvet. Solvet is the type checker and one of the most practical one in the world for Ruby now. Professor Jeff Foster is a researcher in university, and he develops RDL, another type checker for Ruby, and it is his research project. Yusuke Endo is an Ruby committer, and he also develops his own type checking tool called Type Profiler. And I also developed type checker. So we have meetings regularly for 1 year, almost every month, and having discussions about the development of the foundation of type checking for Ruby. And we also share how the progress of each type checker developments, and we discuss about the difficulties, and yeah, and I had some opinions from Mats. Okay, the first thing I have to explain is the goal of the project. So we develop a type checker which detects the type of each Ruby expressions, and it should be done without execution. So the goal of the type checker is to help the development of Ruby programs. So it will find some kind of bugs, including no method errors or some argument errors. It also helps some reading the code. So maybe you have the functionality called jump to definition in your IDEs, maybe in editors. This kind of feature requires a type, I would say that the type of the expressions. So the development of type checkers will help these kind of features. Another one is the refactoring support. So with the exact types of each expression, if we know the type of each expression, it's easier to implement the precise refactoring support, like the renaming constants or renaming a method of a class or renaming instance variables or that kind of things. And on the other hand, performance is not our goal. So performance improvements by type checker is by skipping some kind of the runtime checks during the execution. So it needs much more precise analysis of the Ruby code. So unfortunately, it's really difficult and almost impossible. So performance is out of scope of this project. This is a picture. It is presented in a talk in Ruby Kaigi this year, and it explains 4 key items. Signature of libraries, oops, this one, and signature of application, the level 1 type checker and level 2 type checkers. I'd like to rephrase the plan we have now. So Ruby 3 will provide 3 things. A language to define the signature of Ruby programs, signature of standard libraries, and a protocol to share the signature of gems. This is an example of the Ruby signature language. It has no name yet, but yeah, we will call that. I don't know. So maybe it looks like Ruby a bit. We have a class, we have some mixin, we have a method declaration with def keyword, but the syntax is different. It's another language from the Ruby. So it defines the structure of Ruby programs. So we have the class declaration, module declarations, and interface declarations. Interface is an abstract type. It is not appeared in the Ruby classes, but we need that kind of things to describe some of the type of methods. And you see the include is at the first line of the array definitions, array class definitions. So we write some include, some mix-ins, include, prevent, and extend. We also define the type of methods, type of instances, type of globals, type of constants, and the type language in the signature is pretty powerful. It has generics union types, tuple types, optionals, singleton types, record types, and so on. So I hope that the language covers most of the standard libraries. I believe so, but yeah, maybe we will find some problems. So yeah, it's still work in progress. Ruby 3 will ship with the signature of standard libraries. So to type check your applications, you need the signature of libraries. You need the type definition of libraries. So the library includes standard libraries. It's shipped with Ruby and the gem libraries, the type of any Ruby gems. So if there is no signatures for libraries, you have to write yourself all of the libraries. So it's really exhausting, and I know that you don't want to do that. So Ruby 3 will ship with standard library signatures, built-ins, and some of the built-ins and the standard libraries, including set or path name or that kind of libraries. And we will define the standard protocol to share the signature of gems. So you can write the signature of your gems, and then you can distribute it to around the world, and your library users use the type of the signature to type check their applications. So I want to explain the opposite. In Ruby 3, we won't provide new syntax to annotate Ruby code, and we won't have the standard type checker for Ruby. So Mats says 2 years ago or so, he declared no new syntax will be introduced to annotate the type of Ruby. So it's a bit confusing, so I'd like to explain the detail of. So he says that new syntax for Ruby will be introduced. The syntax means something like this. So in this code, the type of inject method is annotated with something like this. So as you know, this is not a valid Ruby code now. It means that there will be no new syntax. He says that because he don't want to encourage people annotating their code with types, he says that there will be no new syntax to Ruby to annotate the types. So, but unfortunately, years of the challenges, years of developments, we found that we need some kind of type annotations in Ruby code. So we need some annotations anyway. So there are two ways to do that. The first one is using comments. This is what I'm doing in Steep. So this is Ruby code, and this comment is to explain the type of the method. So because the comments are ignored by Ruby interpreters, so this is valid Ruby code. There is no new syntax. Another one is to annotate types using embedded DSLs. So this is what the Solver team is doing. And this is an example of type annotation in Solver syntax. So they define the sig method and the type parameters method and params method, or that kind of things. A big decision we made recently, Mats made recently, is there will be no type checkers for Ruby. There is no the standard type checker for Ruby. So we developed the type checkers. Solver teams had developed Solver. I developed Steep, but the tools are not a part of Ruby 3. So it is because I don't want to say this, but no tool works as much expected. So after having some discussion with Mats, he says that Steep requires too much annotation and he doesn't like this. And the sorbet modeling of duck typing requires extra code and he doesn't like that. And the type profiler is still too experimental. So he decided that type checker will not be a part of Ruby 3. So the plan is this. Ruby 3 will provide a language to define signature of Ruby programs, and signature of standard libraries will be shipped with Ruby, and we define a protocol to share the signature of gems. But we won't provide the new syntax to annotate Ruby code or the standard type checker. So I'd like to explain how the type checking experience in Ruby 3 will be. So we define 3 levels of type checking. The level 0 is it's no type checking, nothing changed in Ruby. It's the same as the Ruby today. Level 1 is we use the signatures of libraries, but you don't have to write the signature of applications. It may find some bugs, but it doesn't find a lot of problems in your code. Level 2 is it requires you to write the signatures yourself, but it detects more problems from your applications. And you can choose the best level for your project. Maybe it depends on the size of project. So if your application is so small or you don't like type checking, you can stay level 0. Nothing will be changed. Or maybe you are interested in finding bugs using type checkers, but you don't have time or resource to write the application signatures, you can try the level 1. Or if your team is big enough or your project is big enough to allow the investment on writing type signatures of your application, the level 2 will detect many problems. And it's up to you, but my recommendation is level 2 at all. Okay, so this is the overview of the plan we have toward Ruby 3 type checking, and I'd like to introduce my type checker. It is called Steep, and I'd like to have some key ideas of Steep. It's structural subtyping, and it allows duck typing, and it's metaprogramming agnostic, and it is static type checker without runtime checks or runtime dependencies. So it is already published as a Ruby gem, and you can install by gem install Steep, or you can see my repositories. I released the latest version 0.11 yesterday to celebrate the Balkan Ruby. So this is an example Ruby program. It's really small Ruby programs. It defines a conference class. It defines 2 attributes, name and talks, and defines 2 methods, initialize and speakers. And at the bottom of the code, there is we make an instance of conference and assign to conference variable, and we use the conference talks method. Oops, I'm sorry. Okay, so this is the signature of the conference class. So this is what you have to write when you use Steep. So the signature is almost the same structure with the Ruby code. There is a conference class, there is a name attribute, talks attribute, and there is 2 methods. So reading the signatures, we find that the name attribute is a string, and the talks is array of talk. We need the definition of talk class and speaker class, but I skip now. So the first thing Steve will do is to detect the bugs on using the classes. So I think that you already found, but the conference new method call is it's long Ruby programs. So because the initialize method of conference class requires a keyword argument, but it calls with a positional argument. So the step will detect an argument type mismatch error. It says the expected type is a name keyword and its value is string, but it's actually called with a positional argument. So it also checks the opposite side, the definition of the conference class. So in this case, the implementation of speakers method is a bug. So I think that the talks.each is the mistake, and we should use the talks.map. So because the array each method returns self, so it returns the array of talk instead of array of speakers. So Steve will detect this error, and it reports the method body type mismatch error. So it should be array of speakers, but implementation is array of talk. So this is a really quick example of what Steve will do. Okay, so back to duck typing. As you know, duck typing is really important feature of Ruby programming. So when you try to find Ruby icons on font awesome, it's a collection of icons. When you try to type the PHP or JS, JavaScript, Python, you will find the icons of the language. But unfortunately, if you try to find the Ruby icon, there's no icon for Ruby. But instead, they show you an icon of duck. So it's proof that the duck typing in Ruby is how important. Yep. Okay, so I'd like to explain the duck typing support on Steve. So this is an example. It's an extension of the previous example. We have a conference class and add a new method like dump titles. It will dump the titles of the talks. So in Steve, we need to define an interface to explain an abstract type. It has a shift operator. It takes a string and returns anything. So the first one is the conference dump title with an empty string. Because the string has a shift operator, it accepts the string, it's okay. Next one is with an array. Array also has a shift operator, and it can be any value, so it's still okay. So the common superclass between the string and array is object, and it doesn't have the shift operator, so it explains how Steve supports duck typing. And it detects more than the duck typing. So if you give an integer to the method, it reports an error. So because the integer, the shift operator of integer is a bitwise left shift operator, it needs an integer argument. So yeah, but the underscore dump2 interface requires it should be a string, so it will be a type error, and Steve detects it. An important feature of Steve is it's metaprogramming agnostic. It means that Steve does nothing about metaprogramming. So most of metaprogrammings in Ruby are done by method calls, like add a reader, include, private, or that kind of things. So Steve doesn't know how the metaprogramming will result, but it detects some type errors on metaprogramming method calls. So in this case, we have it is person class, and we use the ATTR reader. So we want to define two things: the instance variable and the name method. So I mean that you have to expand what will happen after ATTR reader method call. So this is the signature of the person class. It defines the instance variables and the name method. But if you write Ruby code like this, so we should write something like a symbol that colon name, but it has a mistake to you write the capitalize the constant name. So it will find an error. The symbol or string are expected to an argument of ATTR reader, but you write a class. So Steep will find like this. So you may think of this is a huge limitation of metaprogramming, but in my opinion, this is to help metaprogramming. So because that if we support some of the popular metaprogramming primitives, like ATTR reader has many, belongs to, it's okay. So that we can provide some kind of support for that, but it also discourages writing your own metaprogramming primitives. So I know that how much we should metaprogramming depends on, you have some different opinions, but this is my choice. Another one is the Steep is a development dependency. It's not a runtime dependency in your gems. So this is because that the type annotations in Ruby code it's a comment. So Ruby interpreters just ignore them. So if it is an embedded DSL, it requires some extra runtime dependency. So because there will be some kind of the SIG method. So without the runtime library, it will result in no method error. So, but in Steep, it's a comment, so we don't need an extra runtime dependency. I believe that this is better for libraries. If you develop an application, it's okay to have an extra dependency in your application. So because no other Ruby programs will use your application. So having another dependency is your choice and no effects to other libraries. But when you are developing libraries, you develop some gems, it's good to keep the number of runtime dependencies as small as possible. So because your library users want to install Steep. Okay, so this is a quick introduction of Steep, and I'd like to report some of the progress, the current status of the project. Okay, so we develop, I think, about 4 type checkers: Solved, RDL, type profiler, and Steep. So each of the type checker developers develop their own tools independently. We share some experience, we have some discussions, but so we are working for that. And we are also working to define the signature language. It's to define the type of your Ruby program. And I developed a Ruby library to process the type definitions. It passes the signature language and constructs some AST, and build some structure to define the, the inheritance of the Ruby code or some mix-in relations. And it also has a table of methods, which methods are defined in any classes in each class. So the library is available at the github.com Ruby signatures. So you can see how the library is at the report at the URL. And we are also working for the type of libraries. So we are writing the signature of standard libraries, and we will start a discussion for how that type of gems. So it is before starting discussion, this is a proposal. This is my opinion of how to share the signature of gems. So the easiest one is when you want to zip your gems with signature files. So it's easy to understand that you need to include signature files in your .gem files. And additionally, you need to declare that the gem has signatures. So this is an example. It defines a library called Rakia. I don't know what the library is for, but yeah, assume we have the library. So, so in the files attribute, we have the Ruby libraries, rakia.rb, and we also put a signature file, rakia.rbi. So this is to put the signature files in your gem archive. And another one is there is a metadata to explain about some detail of the library. So I'd like to propose a key called signature dir, and it explains where the signature files is stored in the gem files. So it is about the case you want to zip your gems with signatures, and I need some way to the plan B. So this is the situation where we write the TypeScript and the JavaScript. So there are tons of NPM packages written in JavaScript, but some TypeScript developers want to use the libraries. It's untyped, but they need some type definitions. So they run a repository called definitely typed. You can write the types of the NPM packages written in JS. Then you can push the changes to the repository. And the type definitions will be published to the NPM repository as different NPM package. I think that we can do almost the same. So probably we will have another gems for the signature of libraries. So this is an example. Maybe your gem file would look something like this. So you have a dependency to Rails. Version would be 6. And the type of gems should be the type -- Rails or something else. A good thing to use the Ruby gems or bundler is they have sophisticated versioning constraints and the resolving mechanism. So it's easy to detect the fit version of the type definition we want to use. So this is the last slide. So yeah, get ready for types. It will be 1 year and several months. So the first one I'd like to ask you is to give us any feedbacks. You can try the type checkers. Steve is already available as a Ruby gem, and Stripe recently started a beta program for Solvit. You can sign up for the program, then you will have access to the repository. So, and yeah, please test with your application, with your gems, and give us any feedbacks. So we test the type checkers ourselves, of course, but there should be a lot of Ruby programs we haven't tested, so you can test and give us feedback. And another thing is try writing types for your gems or applications. So if you think only a few minutes about how can we write the type definitions, you may find some problems, some serious problems. So if you tell us the feedbacks about that, we will think how we can support your applications. And another one is to sending a patch to add some types of the standard libraries. So this is the library, the repository about the signatures of the standard library. I have done writing the types for basic objects, kernel and object, and maybe array and enumerable, but there are so many Ruby classes left untyped recently. I tried to write that method definition for string, but there are really so many methods, so I stopped writing the types of strings. So yeah, help me, please. So yeah, that's all. So thank you for listening, and please catch me if you have any question or you want to see some demos of Steve. I can show you. So thank you.